Namaste student. Today we are going to start new chapter, that is quadrilateral, and we will try to understand this chapter. So quadrilateral means a four-sided polygon. Four-sided polygon means what? A simple closed figure bounded by four line segment. You can see this figure. This figure is closed. It is simple and line segment. Four line segment you can see here. So this type of figure we call quadrilateral. And another type is also here. You see this part. This is another quadrilateral. As you can see, four sides, four line segment, closed and simple. But what is the difference between these two? We have in our syllabus convex, not concave. This is concave type. So how could I find that this is concave? Just you see that this angle, at least one angle should be more than 180 degree. Then that type of figure we call concave polygon, and if it come under your quadrilateral, then we call concave quadrilateral. But in our syllabus we are going to discuss about convex quadrilateral, and we are going to see that in convex quadrilateral three types. So maybe you may ask that in some book it is showing your 6 types, like separately they are taking a rhombus, square and rectangle, but here we can see in the parallelogram we are keeping this all 3, and this side your trapezium is here. Trapezium is 2 types, you can see, one is isosceles trapezium, another is non-isosceles trapezium, and the third one is kite. So before discussing about this types of this quadrilateral, we need to know about those certain terms like adjacent side, opposite sides, vertices. We are going to see. That means if we take the quadrilateral, then side. If I want to write side, so how many sides are there? 4 sides. What will be the name of these 4 sides? You can give a name AB, another BC, CD, and DA. There are 4 sides in a quadrilateral, and 2 diagonal also. Here, these are diagonal. Already we have discussed diagonal. The diagonal means how many? In quadrilateral there are 2 diagonal. Your name is that AC and BD. These are the name AC and BD. Now angles. So how will I going to represent angle? You may say that angle A, angle B, angle C, and angle D. Or we have a standard form. We can write D angle BAB or DAB. How? BAD. This is the representation. BAD. You say BAD or DAB. So for this one, A, B, C. Symbol will be angle ABC. Okay, there are 4 angles and 4 vertices. How are we going to represent vertices? Just simply take the alphabet A, B, C, D. A, B, C, D. There are 4 vertices, and last one, cover. That is 4 side, 4 vertices, 4 angle, and 2 diagonals. Okay. Now we need to know about the adjacent. So here the adjacent means, if I take here AB, so for AB how many adjacent sides are there? For AB, BC is also adjacent, and for AB, DA is also adjacent. But if you take BC and DA, then they are opposite sides. Remember. Or for this one, AB opposite is what? CD. But if I ask you that what will be the adjacent side for CD according to this question, then adjacent side for CD is CB and another is DA. Similarly, if you go for the angle, if I'll ask you that adjacent angle for A will be B and D. And what about the C and A? They are opposite. Here also angle B and angle D are opposite to each other. So we should know about this term. It will help us to proceed for all types. Now we are going to enter into the types. Now if we'll see the types, we will start with the kite because it's a single part is there. Will not have any other types for this one subtype. So kite we have here. Here you can see this is your kite example we have in our hand. So in kite you can see there I have taken a diagonal. So two diagonal you can see, and the diagonals are perpendicular to each other. Remember, diagonals are perpendicular to each other. That means here we'll get a what 90 degree. And if we take these two sides and these two sides, so you can see that these two sides are equal to each other. Have you seen? Two pair. That means one pair, another is second. So two pair are equal to each other. Have you seen? But they are not equal. You see, this part is not equal to this one, but this one is equal to this. So in kite, this two and this two must be equal, and the diagonal perpendicular to each other. This is the definition. So we have a definition, bookish definition we have. So what we have? Very simply, they have told a quadrilateral which has two pair of equal adjacent side but unequal opposite side. Very simple. Equal adjacent side. See, this side and this sides are equal and adjacent to each other, and this one is also adjacent to each other. But you can see this is also adjacent. If you say, but again, if this is equals to this and this equals to this, that means this must be equals to this. But another definition, with the definition they have given condition that equal adjacent side but unequal opposite sides. So this one and this one are opposite to each other and they are unequal. This condition must be there. So this is your kite. Okay. Next we will proceed for trapezium. So if we will take the trapezium, here we have the trapezium. Now if you see the trapezium, this is your non-isosceles trapezium. So where is the difference between your isosceles trapezium? See, first I'll give a definition for the trapezium. That means a quadrilateral in which one pair is parallel to one another. That means one pair of side. So this is one side and this is your another side, and they are parallel. Parallel means they will never intersect if you will extend indefinitely. Okay, that means in this trapezium, if this part and this part, that means this non-parallel side, if non-parallel sides are equal, remember, if non-parallel sides are equal, then this trapezium will be called isosceles trapezium. But here you can see that this is smaller than this side. That means it is non-isosceles trapezium. Okay, trapezium means one pair of sides are parallel to one another. Next, we'll proceed in a parallelogram. If you see the parallelogram, here we have the parallelogram. In parallelogram, opposite sides are equal to one another and parallel. This is the definition for parallelogram. And then we have lots of property, and we will going to discuss in the next chapter, because separately this chapter has been discussed about the parallelogram because it's very much important. Just we'll go through this one right now. Parallelogram, opposite side, these are opposite side, this one and this one, opposite side, this one and this one is opposite side. So here opposite sides are equal and parallel. That means this part will never intersect if you extend indefinitely from the both direction. And here also if you extend this side and this side, they will never intersect. So this is a parallelogram, and this parallelogram divided into three parts. Now if you see this angle become like this, straight, perpendicular, and this angle also become straight, perpendicular. If both sides become perpendicular, then this parallelogram convert into rectangle. And now if rectangle convert, now remember, if I'll make here and this much if I'll take here, so if you see from this side, so it's look like quite what? Rhombus. Why? Because if all four sides are equal and these angles are not 90 degree. Rhombus means what? All sides are equal to one another, but angles are not 90 degree. So that is a rhombus. So this is also a special case of your parallelogram. Now this rhombus slowly give you 90 degree, then it become a square. Similarly in a rectangle, like if I take rectangle, see in rectangle opposite sides are equal to one another and parallel, and they are making here 90 degree. Here 90 degree, they are making 90 degree. So this is a rectangle, and if all sides are equal to one another and 90 degree, then this rectangle convert into your square. That means square is a special case of rectangle, and square is a special case for rhombus also. So here rhombus, if you see the rhombus, this is your rhombus, and rhombus special thing is what that their diagonals are perpendicular to each other. Similarly, the way we have seen for kite, your diagonals are perpendicular to one another. In this one, diagonals are not equal, but in a square and rectangle, diagonals are equal. So very much important. When we're going to discuss about the parallelogram, we'll enter into the properties deeply and we'll try to understand from there. So for this one, we have this. After that, we have one more topic, that is the angle sum property. What is angle sum property? That means interior angle. Sum of interior angle become what? For triangle, we have seen that sum of angles is 180 degree. Similarly, here also we are going to see the sum of the angles is 360 degree. We have already seen that for triangle. Now we will go for your quadrilateral, and we are going to see few problems in the next video. Till then, thank you.